This study looked at the impact of mid-air haptics on the sense of agency. So by the sense of agency, we refer to the feelings of control over our actions and through these actions causing effects on the outside world. We can explicitly report this experience, or we have implicit measures such as intentional binding, which refers to our perceived compression of time that we experience between our voluntary actions and their subsequent outcomes. There's been an interest generated in human-computer interaction as the user's experience of control over a system is of primary importance. Touchless technology now allows us to interact with these systems without actually touching them. Examples here showing in the surgery setting and also a hand tracking device. These interactions may impact agency given the natural lack of physical touch, so tactile feedback, and also a temporal delay between actual movement and the visual representation. So we address these concerns in the current study by manipulating mid-air haptic feedback and latency for virtual hand movements. Participants were screened for handiness and no reported visual impairments. We measured binding via the direct interval estimation method, and we had explicit reports of feelings of control and causation respectively. The program was set up and run on Unity. An example here of the virtual scene, the participant's virtual hand and the button. Visual representation of how mid-air haptics is provided using ultrasound technology, and the apparatus set up for the experiment. So we have a 2x4x3 within subjects design, 2 levels of haptic feedback with and without, 4 levels of latency for the hand movement, which is 0 to 150 milliseconds spanning equally. We have 3 levels of actual interval, with 36 trials per block. We have a typical trial being they press the button and hear a sound after a pseudo-random interval, and they are required to estimate this interval in a user interface screen. We have every 12 trials, participants explicitly report their feelings of control over the hand and causation between button and sound. With 8 blocks, we counterbalance these to account for order effects. So in this interval estimation errors, lower scores actually equal to greater binding. We found a significant interaction for haptic and actual interval on binding, such that binding differed at the level of haptic feedback depending on the interval length. And this was shown at the longer interval lengths with greater binding in the haptic feedback condition compared to no haptics. For latency, we found a significant linear decrease in control over the hand with increasing latency. This effect did differ at the level of haptic feedback, such that this decrease was significant with no haptic feedback, but no longer significant in the haptic feedback condition. And we see here there was a significant greater felt control in the haptic feedback condition compared to not at the 150 milliseconds level of latency. So to conclude here, we can see that mid-air haptics actually acts to preserve the user's sense of agency at longer action outcome intervals where visual information may no longer be sufficient. We also see mid-air haptics as a sort of mitigator against latency-induced negative effects on explicit control over a virtual hand. Thank you.